Come on, Dumpy, show your stuffy.
This is Dumpy, our one-of-a-kind crime-fighting robot made here at BYU. What makes Dumpy particularly special is the fact that he has four-wheel drive. In order to achieve this, we installed two PIC24 microcontrollers, one to control the sensors and one to control the wheels. Although we accepted the challenge of a little more complexity, this gives us a time advantage when strafing side to side in the canyon or collecting and dropping off balls.
Here is a full 3D model of the robot. Of course we had some changes throughout each milestone, but the base model stayed pretty consistent throughout. A huge plus for being omnidirectional was to be able to strafe to the ball catcher and back. This allows the robot's mitt to always be on one side of the robot. And for the ball drop milestone, we can strafe to either direction and simply dump the ball down the correct slide shown here. Another important aspect was organization. Because of how complex our robot turned out to be, we had much more wiring than expected. Even during the simple milestones, we were taking up too much space for wiring. We designed this organizational plate to simplify the wiring.
Background on how Dumpy does what he does under the hood. So we've got our two microcontrollers. The navigation pick is our master pick. It's connected to our sensors. And so under the hood, it needs to be scanning for what task it needs to be doing. And we do that after configuring in Dumpy's favorite game. So here we keep track of what we have done so we don't keep looking for it. And we also know if we didn't pick up the ball, we can't do the tower. So it keeps track of that. And then in each of these functions, it'll go in and it has specific instructions for it. And when we go into a state, when something's triggered, we send the actions that the robot needs to take to the motor pick. And in the main loop on the motor pick, we are always reading what that word is. And then we have a state machine that reads off whatever state we're in and does the action.
There were a lot of things we learned as we built this robot. One thing was we learned that we needed to calibrate all of our sensors individually, since there was quite a bit of variation between some of our sonar sensors particularly. So next time we'd like to start with that, because we lost a lot of time trying to figure that out. Another thing we lost a lot of time on was our debugging procedure. We often came at problems in a haphazard way. Next time, we would like to document our testing results every time and write them out so we can see them better and create a more robust debugging procedure so that we don't get lost and forget what we were trying to fix in the first place. Even so, we're very happy with the way the robot turned out, and we learned a lot through this experience. That failure was expensive.